All right, so today we're going to be taking a deep dive into some vintage tech.
Oh, cool.
Yeah, we've got a whole stack of documents here all about the system object model.
SOM?
SOM, that's right.
Yeah.
Late 80s, early 90s. This was the cutting edge.
Wow.
And I know...
That's before my time.
Yeah.
Yeah.
System object model. It doesn't exactly sound like the most riveting topic, but trust me.
Okay.
This stuff is really fascinating because this is about how we build software, like the very building blocks of the programs that we use.
Yeah, I can see that.
So think of it like this.
Okay.
Before SAM came along, programmers were constantly reinventing the wheel, right? They were writing the same code over and over and over again.
Yeah, that makes sense.
And Nelson was really trying to solve that problem,
Yeah.
to bring some order to this.
I think one of the things that's so interesting about these documents is that they capture this moment, when programmers were really struggling with the limitations of systems like DOS. And SOM was this kind of new way of thinking about software.
Yeah, absolutely. And you know what I thought was such a great example of this?
Yeah.
One of the documents actually mentions how even in the old CPM operating system, the BIOS code was acting like a very primitive device driver.
Uh-huh.
A way to let the OS talk to the hardware.
Oh, that's a great example.
Yeah.
Because that BIOS code was essentially doing what SOM would later do, but on this much grander scale, creating these reusable components that could bridge the gap between software and hardware.
Exactly.
Yeah.
Yeah, so SOM was trying to solve this real problem that had been around for a while. But for those of us who aren't, steeped in this history,
Sure.
What exactly is a SOM? Can you give us the definition?
So SOM at its core is a way to design and build software components that can be used and reused in different programs. And these components are called objects.
Okay.
And they're like building blocks.
Like Legos?
Exactly like Legos, each with its own specific function.
Okay, so instead of writing code from scratch every time, you could use these kind of pre-built objects, like snap together Lego pieces to make different creations.
Exactly. And that's where this SOM architecture comes in.
Right.
It's built around these key concepts like objects, classes, methods, and inheritance.
All right, so let's unpack that a bit.
Yeah,
We've
sure.
got the objects.
Yeah.
Those are our Lego pieces. What are classes in this analogy?
So think of a class as the blueprint for the object.
Okay.
It defines the object's characteristics and capabilities.
Got it.
So if our object is a button on a screen,
Okay.
the class would define what a button looks like, what data it holds, how it behaves.
So the class is the blueprint.
Yes.
The object is the actual instance built from that blueprint.
Right.
All right. And then we have methods.
Yes.
What are those?
Methods are the actions an object can perform.
Yeah.
So sticking with our button example methods would be things like display the button, change the button's color, or detect when the button is clicked.
Okay, so methods bring our objects to life.
Yes.
They let them do stuff.
Exactly.
Okay, this is all starting to click into place.
Good.
We've got our objects, the blueprints, classes,
Yeah.
and the actions method.
Yes.
And what about inheritance?
Inheritance.
That sounds pretty powerful.
This is one of the most ingenious parts of SOM.
Really?
It lets you create new classes based on existing ones, inheriting all of their characteristics, and then adding or modifying features.
Okay.
So let's say you wanted a special kind of button, say a button that glows.
Okay.
You wouldn't have to rewrite all the basic button code from scratch.
Oh, wow.
You would just inherit from the existing button class and just add that glowing feature.
Saves so much time.
Exactly.
Programmers must have been so excited when this came out.
Oh, yeah.
All right, so we've got the building blocks, objects, the blueprints, classes, the actions, methods, and this way to build upon existing blueprints, inheritance. That's a pretty solid foundation.
It is.
But how do you actually program with SOM? What does that look like in practice?
So one of the documents we have here,
Yeah.
1995 OS2 Warp Programming for Dummies Watson.pdf, walks us through some basic SM programming.
OS2 Warp Programming for Dummies.
Yeah.
Nice.
It uses examples like creating a spin button,
Yeah.
those little up and down arrows
Oh, yeah, sure.
to adjust values.
Yeah.
So this document actually shows you how to build a spin button using SO.
So you can see the concepts in action.
Exactly.
It's not just theory anymore.
Yeah.
You can actually see how to build something.
We're building something real.
That's really cool.
Yeah. And what's really interesting is that the document also highlights how SO makes it easier to connect those graphical elements like our spin button to the underlying code that makes it work.
Oh, okay.
You create these links between the visual components and the methods that handle all the logic.
So instead of having this big jumbled mess of code,
Yeah.
Everything is kind of neatly organized.
Exactly. SOM brings structure and modularity to the programming process.
That makes a lot of sense. Okay, so we've talked about what SOM is and how this architecture works, but why should anybody care?
Yeah.
What are the benefits of using this system? What makes it so special?
Well, the benefits of SOM are really substantial,
Yeah.
and they've had a lasting impact on software development even to this day.
Wow.
One of the biggest advantages is reusability.
Okay.
Instead of rewriting the same code for common elements,
Yeah.
programmers can use these pre-built objects,
Right.
saving time and reducing errors.
That makes sense.
Reusability is huge in any field,
Absolutely.
but especially in programming.
Yeah, where things can get really complex really fast.
Exactly. So what other benefits did SOM bring to the table?
Well, closely tied to reusability is flexibility.
Okay.
Because SOM objects are modular,
Mm-hmm.
you can easily modify and extend existing software without having to rewrite everything from scratch.
That's huge.
Need a new type of button, no problem, inherit from the existing button class, and just add your custom features.
So it's like having these adaptable Lego pieces.
You can modify them to fit your specific needs.
That's a great way to put it.
What else?
Well, SO also encourages a more organized and structured approach to programming.
Okay.
By breaking down software into these well-defined objects,
Yeah.
it becomes much easier to understand, manage, and maintain.
It's like when you have a Lego set
Yes.
that have those separate bags for different parts of the model.
Right.
Everything has its place.
Exactly.
It makes the building process so much smoother.
Precisely. And that structured approach also leads to more robust and reliable software.
Okay.
When you have these well-defined objects with clear responsibilities, it's easier to identify and fix bugs,
Uh-huh.
and the overall system is more resilient to errors.
So it was a win-win for both programmers
Absolutely.
and users.
It made development faster and more efficient,
Yeah.
and it resulted in better, more reliable software.
Makes sense.
And the impact of SOM goes beyond those immediate benefits.
Really?
Its principles of reusability, modularity, and object-oriented design, they laid the foundation for many of the technologies that we use today.
That's an incredible legacy
It really is.
for a technology that emerged, decades ago.
Mhm.
Like, SOM planted the seeds for the way we build software today.
It did.
I'm really starting to appreciate the ingenuity of this system.
Yeah.
But I'm curious, were there any challenges that programmers faced when they were working with SOM? Was it all smooth sailing?
Well, while SOM offered all these advantages, it
Yeah.
did present some challenges as well.
Right.
One of the main criticisms was that it could be complex,
Ah.
and it required a shift in thinking for programmers who were used to more traditional procedural programming.
So it was a powerful tool,
Yes.
but maybe not the easiest to master.
Right. Learning to think in terms of objects and classes
Yeah.
and understanding concepts like inheritance and polymorphism
Right.
required a new way of approaching software design.
Yeah, I can imagine it took people some time to really wrap their heads around that.
Absolutely.
Especially those who are used to the old ways of doing things.
It was a big change.
Right.
And while the concept of reusable components was brilliant,
Yeah.
managing and sharing those components could also be tricky.
Oh, okay.
Remember we were talking about global selectors earlier? Well, they were part of a system to efficiently locate and access SOM objects, but it did add another layer of complexity.
Yeah, so even with its challenges, SOM was a significant step forward in software development.
It was.
It pushed the boundaries of what was possible
Yeah,
and introduced concepts that are still relevant today.
absolutely. And those challenges led to further innovation
Of course.
as developers sought ways to make SOM more user-friendly and more efficient.
Yeah, it's a fascinating story of how technology evolves, driven by both its strengths and its limitations.
Exactly.
Well, this has been an enlightening deep dive so far.
It has.
We've explored what a SOM is, how it works,
Yeah,
and its lasting impact on the software world.
right.
But there's still so much more to uncover.
There is. In
Nice.
our next segment, we're going to delve deeper into how SOM was used in practice,
Oh,
exploring specific examples and code snippets that really showcase its power and versatility.
can't wait.
Get ready for some real hands-on insights.
Awesome. All right, so we're back.
Yes.
And we're ready to get into the nitty-gritty
Let's do it.
of the System Object Model, SOM, how it actually worked in practice.
Okay.
You mentioned code snippets and examples.
Yes.
That's what I'm really excited to see.
Okay, well, these vintage documents are a goldmine of practical insights.
Okay.
And one that I think is particularly interesting
Yeah.
is 1997 Power GUI programming with Visual C plus Hiroshitsuji.pdf.
Wow.
It really dives into building graphical user interfaces, or GUIs,
Okay.
using a SOM.
GUIs, that's what we interact with directly, right?
Yeah.
Like
Yeah.
the windows and the buttons,
Yep.
the
Yeah.
menus, all that visual stuff.
Exactly, all that stuff.
Yeah.
And this book gives us a peek into how SOM made it easier to create those interfaces.
Okay.
So, for example, it shows how to build something called a multi-cell canvas.
Multi-cell canvas.
Think of it like a grid or spreadsheet-like area
Right.
within a window.
Yeah, I can picture that.
Okay.
What's so special about building that with SOM?
Well, what's fascinating is that the book shows how SOM lets you create these complex visual structures by combining and arranging simpler objects.
Mm-hmm.
You essentially build this hierarchy of objects with the canvas as the parent and then the individual cells as its children.
So it's kind of like
Yeah.
building a house out of Lego bricks.
Yes, exactly.
You have the overall structure, the walls, the roof, and then you fill in the details with all these smaller pieces.
That's a great analogy.
Yeah.
And the beauty of SOM
Yeah.
is that it provides this standardized way to define the relationships between those objects.
Oh, okay.
You can specify how the child objects are positioned and arranged within the parent object. And you can control how they interact with each other.
It sounds like SOM brings a lot of order and structure
It does.
to what could otherwise be a really chaotic process.
Yeah, absolutely.
I can see how that would be incredibly valuable
It was.
to programmers.
Yeah, and that structured approach is reflected in the code examples.
Okay.
You can see how the author uses SOM methods to manipulate the objects.
Yeah.
Things like adding new cells to the canvas, resizing them, or changing their contents.
So SOM provided a way to build those user interfaces in a way that was logical and organized and efficient.
Exactly. And because SOM objects are reusable,
Right.
you could take that canvas object or parts of it
Yeah.
and use it in other programs
Oh, wow.
without having to rewrite the code from scratch.
That reusability just keeps coming back.
I know, it's powerful. It's
Yeah.
like having a library of pre-built GUI components
Right.
that you can just mix and match to
Wow.
create all these different interfaces.
Okay, so that's the multi-cell canvas. Do these documents have any other
Oh, yeah.
interesting examples of SOM in action?
They do.
Okay.
So another document,
Mhm.
1995 OS2 Warp Programming for Dummies Watson.pdf, focuses on a different aspect of GUI programming,
Okay.
handling user input.
All right, so how does SOM help with that?
Well, remember how we were talking about how SOM objects have methods?
Yeah, actions they can perform?
Yes, exactly.
Right.
This document shows how you can use SOM to define methods that respond to specific user actions.
Okay.
Like clicking a button or pressing a key.
So you're basically associating code with those user interactions.
Yes, exactly.
Okay, but how does that actually work in practice?
So the book uses the example of a spin button again.
Okay, spin buttons, yeah.
It shows how to define methods that are triggered when the user clicks the up or down arrows
Okay.
on the spin button.
So when the user clicks the up arrow,
Mm-hmm.
a specific method is called to increase the value.
Yes.
And when they click the down arrow, a different method is called to decrease the value. Okay, so it's all very neatly
It's very organized.
organized and controlled.
And what's really neat
Yeah.
is that SOM provides this standardized way to handle these events.
Okay.
You don't have to write custom code for every single user interaction.
Right.
You can use SOM's built-in mechanisms
Yeah.
to manage those events.
That sounds like a huge time saver.
It is.
It is.
It also helps to make the software more reliable
Oh, okay. Okay.
because by providing this consistent framework for handling events,
Yeah.
SOM reduces the potential for errors.
Right.
And it makes it easier to debug and maintain the code.
So that's building those visual elements of a GUI,
Mm-hmm.
handling user input.
Yes.
Is there anything else that SOM helps with in this kind of GUI programming world?
Yes. Actually, another document,
Okay.
1989 Advanced OS2 Programming rayduncan.pdf, goes into detail about window procedures.
Okay, remind me, what are window procedures again?
Think of them as the brains of a window.
Okay.
They control how a window behaves and responds to different events like being resized, moved, or even closed.
So they're like the command center for each individual window.
That's a great way to put it.
Okay.
And what this book highlights is how SOM simplifies the process of creating and managing these window procedures.
Okay, I'm all ears. How does it do that?
Well, traditionally, writing window procedures could be quite complex and involved a lot of low-level code.
Right.
But SOM provides this higher-level abstraction that makes the process more manageable.
Okay.
It allows you to define the window procedure's behavior in a more structured and object-oriented way.
So instead of getting bogged down in those nitty-gritty details, programmers could focus on the bigger picture of how the window should function.
Exactly. SOM took care of a lot of the underlying plumbing,
Okay.
allowing programmers to work at a higher level of abstraction.
That must have been a welcome relief for developers.
It was.
It's like having a team of expert plumbers take care of all the complicated pipe work, so you can focus on designing the bathroom itself.
That's a fantastic analogy. And
Yeah.
this higher level of abstraction was one of the key benefits of SOM.
Okay.
It made programming more efficient
Hmm.
and allowed developers to create more complex and sophisticated software.
Okay, so we've seen how SOM brought order and structure to GUI programming,
Yes.
from building the visual components to
Mhm.
handling user input to managing window procedures.
Right.
It sounds like it was a real game changer for developers working in that domain.
Absolutely. SOM revolutionized the way graphical user interfaces were created,
Wow.
making the process more efficient, more reliable, and ultimately more enjoyable for programmers.
All right, this has been a fascinating deep dive
It has been.
into the practical side of SOM.
Mm,
We've seen how it was used to build real-world applications,
yeah,
and I'm really starting to appreciate its elegance and its power even more.
indeed. And as we move on to our next segment,
Okay.
we're going to explore the broader impact of SOM,
Okay.
its influence on other technologies, and its lasting legacy in the world of software development.
All right, so we've really gotten into the nuts and bolts of SOM.
We have.
Um, but now I'm curious about the bigger picture, like where does SOM fit into the grand scheme of things? How did it influence the software development world?
That's a great question. SOM's influence is significant and far-reaching.
Okay.
One area where it had a major impact was in the development of distributed object technologies.
Okay.
Think about it this way.
Yeah.
SOM enabled objects to talk to each other
Mm-hmm.
within a single program.
Okay.
But what if you wanted objects on completely different computers to communicate?
Ah, that makes sense. It's like taking the idea of objects and scaling it up to a network level.
Exactly. And that's where technologies like Corba and DCOM come in.
Okay.
They were heavily influenced by SOM,
Uh-huh.
and they allowed objects to interact across networks regardless of the underlying operating systems or programming languages involved.
So objects on a computer in London could talk to objects on a computer in Tokyo, all thanks to the principles established by SM.
Exactly. And this ability to build distributed systems had a profound impact on the way software was developed.
Yeah.
It paved the way for client-server architectures, web services, and all sorts of other distributed applications that we rely on today.
It's amazing to think how SOM, which was initially designed for building GUIs and streamlining software development on a single machine, ended up playing a key role in the rise of the interconnected world we live in today.
It's a testament to the power of good ideas
Yeah.
and how they can ripple outwards, influencing seemingly unrelated fields.
Absolutely.
And SAM's influence doesn't stop there.
Okay.
Its principles of reusability, modularity, and object-oriented design have continued to shape the way we build software, even in modern programming languages like Java and C#.
So even though SOM itself might not be as widely used today, its legacy lives on
It does.
in the tools and techniques that we use every day.
Absolutely. The core ideas behind SAM, like encapsulation, inheritance, and polymorphism,
Right.
are fundamental to object-oriented programming, which is still the dominant paradigm in software development.
Well, this has been an incredible journey
It has.
through the history and impact of SOM.
Yeah.
We've gone from understanding its basic building blocks
Right.
to seeing how it revolutionized GUI programming
Mm-hmm.
and ultimately influenced the development of the internet as we know it.
It's a fascinating story of innovation
Yeah.
and how seemingly small ideas can have a massive impact on the world.
And I think it highlights the importance of looking back at the history of technology.
I agree.
Sometimes the solutions to today's problems can be found in the innovations of the past.
Well said. So as we wrap up this deep dive,
Yeah.
let me leave you with this thought.
Okay.
SOM was a powerful tool for its time, and it paved the way for many of the technologies we use today. But technology never stands still.
That's true.
What do you think is the next SOM? What are the new paradigms and approaches that will shape the future of software development?
That's a great question to ponder, and one we might just have to explore in a future deep dive.
I'd like that.
Until then, keep exploring, keep learning, and keep questioning. That's the spirit of SO and the spirit of innovation itself.